In this video, we're actually going to calculate the coefficients of a linear regression, slope, intercept, r squared, on the data set that we used in the last lesson. We've done this in a traditional programming language. If you've taken the C course, for example, from me, and it's a pretty long and involved program, what you're going to see for MATLAB is how concise and efficient vectorized code looks like. And so very, very complex equations can become very, very simple looking in MATLAB and Octave. It's a really useful tool. It'd be hard to believe that this is not an extremely useful tool. Very handy for the average person doing computational work. Okay, so step one is to start with the folder that we had last time, load data. So you go into File Manager and you click and you find load data, you click on it, make a copy of it. Then I'm going to change the name of that to linreg1, not linreg. Let's make sure it's linreg1. Linreg is going to be something else later, so that's why I want to reserve that name for something else. That's why I'm telling you to just call it linreg1 now. Okay, so then when you go into that folder and you see loaddata.m, just change the name of that to linreg1.m. Then I'm going to open up Octave, so Octave gets open up, and I want to change the folder, the directory, to linreg1. So I go in, I go up, and I do browse, and I find the linreg1 folder, and I choose, and I hit the choose button, and so now I'm in the right folder. If I edit linreg1.m, if I type out edit linreg1.m, then linreg1.m, which is really just load data, comes up. And if I run it at the command window, it comes up, and in the workspace you see the variables, and you see the thing come up with the little red circles. R0 is for red circles, right, in the plot command. So everything looks fine, right? It works the same. So below that, I'm going to add how you calculate the slope and intercept and r squared. Shown here are the equations. You can see the equations. A lot of sigmas, right? Sum of x, sum of y, sum of x squared, which is x times x, sum of y, y squared in parentheses, that's y times y, and sum of xy, which is x times y. And this is all row by row calculations, so it'd be, in MATLAB, it would be x dot times x dot times y dot times y, etc. So I'm going to make a whole bunch of variables, sum x, sum y, sum xx, sum xy, sum yy. Those are all the 5 sums that I need to be able to make all those calculations that you see. I also need the number of points, so I'm going to make n the number of points in Octave, in MATLAB. So I go back to my editor in linreg1, and I come up with all those sum values. Sum x equals sum parentheses x. Sum y equals sum parentheses y. So then with all the other ones we have to multiple ones, I say sum xx equals sum in parentheses x dot times x. Sum is a built-in function for Octave and MATLAB. That was the missing link there, right? It's good. So, and then at the end, I want to do the n. So n is just the length of one of the vectors, length of x, right? 10. It's going to come up as 10 points. So m, if you look at the equation there in Octave, it's the same as the mathematical expression there. Sum n times sum xy minus sum x times sum y divided by n times sum xx minus sum x times sum x. So sum x all squared is sum x times sum x. Sum x in parentheses squared is sum of x dot times x. So it's different. They're not the same. You can sort of prove that to yourself with very, very short vectors and do the different calculations and show that those two operations aren't the same. Okay, so that's the slope. Then the intercept is, I'm just going to use the mean value. I could have said sum x divided by n and sum y divided by n for the mean, but I'm just going to use mean. Mean is the average value, and mean is a built-in function in Octave and MATLAB as well. So b is just mean y minus m times mean x. right? Then same with R. And you need the square root function. So SQRT is the square root in Octave and MATLAB. And so I just put SQRT in the bottom, and you can see the equation matches. Again, it matches the mathematical expression there. No problem. And I want R squared. I don't really care about R that much. So I usually look at R squared when I look at linear regression. And so R squared is just R times R. R is a scalar, so I don't need to use dot times there. You could use dot times. It wouldn't change the output, but with a scalar times a scalar is, you can just use times and divide and things like that when you're only talking about scalars. Good? Okay, so that's it. Now, notice at the end, I just say MBR2. I could, to print them out to the command window so you can see what their values are, right? So that's how I look at the data. Now you could have, when you calculate M with the slope, just take the semicolon away and you would have gotten the same answer. I kind of like to do all the calculations and then just report them out at the bottom. Sometimes it's, you can do that. You can do it either way. It doesn't matter. It's just a horse apiece on that one. Good. So let's save it, Control S, and let's run it. And so we run it with those equations, and you can see the slope, intercept, and R squared. And you can go into Excel and compare them and see if you get the same answer. And of course you will. That's the right. Of course you're going to get the same answer. It works. The last thing is let's plot the regression line on there. So in order to do that, we need to talk about this function pause, right? So what pause did was, if I put pause after plot x, y, comma, the first plot command, right? What it does is it waits for a keystroke. So then you get a chance to look at the first thing that comes up is the original data. So you can look at the original data, say, yeah, I'm happy with that. Then you can press the space bar. I always press the space bar. You can press any key, right? I press the space bar, and then it goes on and does the rest. It prints out the answer. I'm going to add another plot command at the bottom here. And that plot command is going to have x, comma, y, comma, red circles, right? And then the linear regression line. So x, comma, m times x plus b, comma, and then I wanted to make it a blue line. So in quotes, b dash. So that's the regular straight line, no dots or dashes or anything like that. So let's run, when we run the script there, we save it, then we run the script, the first plot comes up with just the data, I look at it, everything's fine, I press the space bar, and then the second plot comes up with the line through it, and then you can see that the slope, intercept, and R squared showed up on the command window. And so that way you can actually see the regression value. That's it. That's how you do the linear regression in Octave and MATLAB. Boy, is it easy and fast. Very, very small number of lines to get the regression output.